Why is the double-slit interference experiment considered the most terrifying physics experiment in the world? 17th century? The Dutch scientist Huygens first proposed the wave theory of light, stating that he believed light propagates like water waves. When two beams of light meet, interference creates alternating bright and dark patterns. However, the examples provided by Newton, using his authority in physics, ruled in the expansive 18th century landscape until 1807, when UK physicist Thomas Young validated wave theory through the double-slit experiment that let light pass through two narrow slits in a barrier. If light were particles, the screen would show two clear, bright stripes. If light were waves, then it would form stripes like a zebra pattern from interference. The results aligned with Young's prediction. Interference patterns confirmed wave theory's success. It also completely shattered people's inherent perceptions of light. 20th century quantum mechanics revealed the double-slit experiment's nature. Scientists upgraded the experiment to single photon emission, greatly enhancing its capabilities. Emitting one sample at a time, every individual photon, at least in theory, could only pass through one of the narrow slits, couldn't interfere. The display should clearly indicate two bright stripes when they appear. The results were surprisingly unexpected. As the number of photons accumulated, interference patterns astonishingly reappeared on the screen, questioning who the photon was with, disrupting normal processes. This notable question became a puzzle for physicists, and to unravel the mystery, scientists placed detectors before the double slits, attempting to observe the paths of the photons. An even stranger phenomenon occurred. When the detectors were turned on, interference patterns gone, leaving two bright stripes. Patterns returned after detectors were off. Photons appeared conscious, ability to sense if they were observed. And based on that switch between wave and particle states, this discovery stunned the scientific community. The act of observation itself altered the results of the experiment. Microscopic particles no longer acted independently of the observer. To explain this phenomenon, Einstein introduced light quanta. All light is composed of particles exhibiting duality, being particles and waves based on observation. The Copenhagen interpretation of quantum mechanics stated that before observation takes place, microscopic particles exist in a quantum superposition, not just wave, nor solely particle. When observation collapses wave, does the particle present a definite state? This gave a debate between Einstein and Bohr, where Einstein firmly believed that God does not play dice. Reality follows deterministic laws. Bohr firmly upheld his view on the inherent randomness of quantum mechanics, the vital role of careful observation. To delve deeper into quantum mysteries, scientists designed a delayed choice experiment. They moved detectors behind the double slits, deciding to observe only after the photons passed through the slits. The results were again shocking. No matter when the detectors were turned on, as long as observations were made, the interference patterns would vanish and vice versa. This implied future observations influence the past, making time's causality nuanced in the quantum realm. This phenomenon exceeds classical physics, made scientists rethink space-time relationships and observation. Moreover, the quantum erasure experiment further deepened this strangeness. Scientists used quantum entanglement to get path info from photons post-double slits. It was found that interference patterns reappeared. It impacts the existence of results, but it also determines the behavior of particles. The bizarre and perplexing nature of the unpredictable quantum world seems to transcend human understanding. Just as Bohr stated, before observation occurs, no physical quantity exists objectively and challenging. This belief provokes philosophical inquiries about the nature of reality. Is the observed world independent? Are scientific theories just human accounts of nature? Rather than presenting an absolute truth that allows no interpretation? Is scientific theory merely a description of nature by humans? It's not an ultimate truth set in stone.